Hello everyone. We're here for today's mini lecture on systems of nonlinear equations in two variables. So, you've probably already discussed systems of linear equations in two variables. As you remember, there were three ways to solve, either graphically, or by the substitution method, or by the addition-elimination method. Well, we can use all three of those methods as well for solving systems of nonlinear equations in two variables. What are they? Well, they're two equations that where at least one of them cannot be expressed in the form of ax plus by equals c in the form of a straight line. So if you take a look at our example here, we have x squared minus 3y equals 10 and x squared plus y squared equals 50. Well, the first one is a parabola. The second one is a circle. So we have the equation of a parabola and the equation of a circle. In other examples, we may have some other figures. We could have a circle, and maybe one equation could be actually a straight line. So we want to see where they intersect, where the graphs and the lines of the graphs cross. This will be our solution. Where they intersect is an ordered pair. Our first example shows a system of nonlinear equations in two variables. The first equation is xy is equal to 8. The second equation is x plus y plus 6 is equal to 0. So, to solve this one, let's go ahead and use the substitution method. Looking at these two equations, I can choose either one, the top one or the bottom one, and then choose to either solve for x or for y. There's no right or wrong in this. It's totally your choice. Myself, I'm going to take the xy is equal to 8 and solve for x. So to solve for x, I need to get it by itself. Therefore, I understand that we have x times y. So I'm going to do the opposite or inverse of that, which is division, and divide both sides by y. In dividing both sides by y, on the left side the y's cancel out, and I'm left with x is equal to 8 over y. Alright, so this first part is very important for us. We just solved for x, however, not quite. So we're going to take what we've just found for x being 8 over y, and we're going to plug this in to the other equation that we haven't touched yet. So we took the xy equals 8, solved for x, and now we're going to use the x plus y plus 6 equals 0, and we're going to plug this in for x, right? Because we just said down here that x equals, or x is 8 over y. So we substitute 8 over y in for x, plus y plus 6 equals 0. Alright, so the next thing I want to do here is likely just get rid of the fraction. So anytime we have a fraction, all we need to do is check out the denominator. Whatever the denominator is, we can take that denominator and multiply the denominator times each of these terms. Right? So in multiplying the denominator times each of these terms, especially times the first one, this is what we are actually doing this for, to get rid of the fraction. Y times 8y, the y's can cancel out and you're left with just the 8. Y times y gives us a y squared, and 6 times y is 6y is equal to 0. Alright, now looking at this even further, you have to really look closely and understand that the largest exponent within all of these terms is a 2. That tips you off to something important. It tips you off that this is a quadratic equation, right? When your largest exponent is a 2. It's a quadratic equation. So now you have to just recall from your algebra skills and say, when I solve a quadratic equation, I need to put it in standard form, or meaning put everything on one side and 0 on the other side. Well, luckily, everything is already on one side for us. I'm just going to put it in descending order. Y squared plus 6y plus 8 is equal to 0. The next step to solving a quadratic equation is just to go ahead and factor. So here, the leading coefficient is a 1, so this is one of the easier ones to factor, because all we need to say is what times what? 2 factors of 8. That's what we need. What times what gives us 8? And those same two numbers have to either add or subtract to make a 6. So that looks like a 4 and a 2, right? And we just have to get our signs right. A positive 4 and a positive 2 when multiplied make a positive 8. And positive 4 added to a positive 2 will get us this 6. The next thing we need to do is apply the zero factor property. So we say y plus 2 equals 0 and y plus 4 equals 0. Then just solving those resulting equations, we get y equals negative 2 and y equals negative 4. Alright, so the solution to systems, whether it's a linear system or nonlinear system, is going to be an ordered pair, right? That ordered pair is where those two graphs cross, where they intersect at a certain point. Well, we have half the battle done for us, because remember, an ordered pair is an x comma y. Well, we found the y values. Alright, so now we're going to plug both of these y values in to one of the two original equations. So I'm just going to use that xy equals 8 again, and I'll write it on both sides, and I'll draw a little dotted line between the two just to separate the two. So now I'm just going to plug in a negative 2 in for y. So x times negative 2 is negative 2x is equal to 8, right? Or you could very well write x negative 2, same thing, right? X times negative 2, but it looks much better, and we won't confuse ourselves if we write it as negative 2x. If we write x negative 2, we would have to probably be sure to write a dot in between them or put them both in parentheses. Alright, in solving for x, we just divide both sides by negative 2, and we get x is equal to negative 4. Alright, let's look on this right side here. So substitute in the negative 4 for y. So x times negative 4 is negative 4x is equal to 8. And then we can say to ourselves, let's divide both sides by negative 4, and x is equal to negative 2. Alright, so remember, our solutions will be ordered pairs. So this ordered pair is negative 4 comma negative 2, right? Negative 4 and negative 2. And then this second order pair is negative 2 and negative 4. So the solution to this system of nonlinear equations in two variables is negative 4 comma negative 2, and the other solution is negative 2 comma negative 4. If you wanted to go ahead and check, which is what I would do on a test or a quiz, I would plug in negative 4 in for x and negative 2 in for y. Do that for both of the equations, and it has to work for both of them to be a solution to the entire system. And then do the same thing for the other one, and they should very well work out. Let's try a second example. This time, instead of using the substitution method to solve the system, let's try the addition method, or sometimes it may be referred to as the elimination method. Alright, so in this method, we're going to try to have either the x's, or in this case, it would probably have to be the x's. We'll have to make them zero out To zero out, to eliminate, they have to both be opposites. So right now, the x squareds, they're not opposites. They're both the same. One of them would have to be a negative for them to then eliminate or zero out. There's nothing else here that we could have zero out. We would like to get one of the variables to do so. And it looks like the x squareds are the ones that we'll look to have that happen to. Alright, so what I'm going to do is just go ahead and multiply that top equation by -1. Let's see what we get. We get negative x squared plus 3y equals -10. Alright, the bottom equation I didn't touch, so it remains as x squared. And I'm just going to move the y squared over a bit just so it's not under the 3y because they're not like terms. And it's equal to 50. I'll draw my line and now do my math vertically. Well, if you look at what we have, a negative x squared and a positive x squared, they'll eliminate or zero out, which is what we wanted to happen. We always want to make the variables, or one of the variables, zero out. So then we're left with y squared plus 3y equals 40. Alright, so in the previous example, I said that you had to take notice of the largest exponent being a 2. We do so here as well. Since the largest exponent is a 2, we know that this is a quadratic equation. To solve a quadratic equation, everything must be on one side with 0 on the other. So we're going to have to subtract 40 from both sides. So that will give us y squared plus 3y minus 40 equals 0. So now it's in standard form. We can go ahead and solve this quadratic equation, and we start off solving by factoring. Here we're saying to ourselves, since the leading coefficient is a 1, all we need to ask is what times what will make -40, and the same two numbers have to add or subtract to make a +3. To me it looks like we're going to use a 8 and a 5. 8 times 5 is 40, and 8 and 5 will somehow get you 3 if you add or subtract them. We just have to get our signs right. So it should be a +8 and a -5, right? Because a +8 and a -5 will get us a +3. We have to make sure that those signs are right. If the signs were swapped, it would have given us a -3, but we want this +3. And then we check again. A positive times a negative does get us this negative in front of the 40. The next step is to use the zero factor property. Y plus 8 equals 0 and y minus 5 equals 0. Solving the resulting equations, we get y is equal to -8 and y is equal to +5. Alright, so now we just go ahead and do some back substitution and substitute the -8 and also the 5 into any one of the two original equations. So I'm just going to pick that first equation that was in our problem, the x to the second power minus 3y equals 10. X to the second power minus 3y equals 10. I'll write it twice because I'm going to substitute the two y values that we have found. Alright, so I'm just going to plug in for y, right? Because it says y is equal to -8. I'm just going to plug it in right there. So x squared minus 3 times -8 equals 10. And same thing with this side, x squared minus 3 times -8 equals 10. And I apologize. For that right hand side, I'm plugging in a 5, right? Because y is 5. Alright, so let's keep on going with this, and we get x squared plus 24 equals 10. we look like we need to get the x squared by itself, so we'll subtract 24 from both sides of the equation. Subtracting 24 from both sides of the equation. So x squared will equal to negative 14. To solve this, we use the square root property, take the square root of both sides. But if we have that, we'll get x is equal to plus or minus the square root of negative 14. Alright, so that's not looking good for us, right? Because we can't take the square root of a negative number. If we do, we're going to have to start dealing with imaginary numbers. So this doesn't work for us. We're just going to have to cross that out and go ahead and work through the other side. So we have x squared minus 15 equals 10. And now we're going to go ahead and add 15 to both sides to get the x squared by itself. So we get x squared is equal to 25. Take the square root property, so we get x equals plus or minus the square root of 25. So x is equal to plus or minus 5. Alright, so looking back, we can't use that left-hand side, so we can't use the y equals negative 8. We go back and say, okay, we have x equals positive and negative 5. So we're going to have an order pair of 5, comma, and what was our y value? Well, our y value was a positive 5, right, that we substituted in, that we found earlier. And then going back to the x value, we have a negative 5. So we're going to use that as well. So we're going to use negative 5. And again, what was the y value? The y value was this positive 5 up here. So the solution or solutions to this system of nonlinear equations is 5 comma 5 and negative 5 comma 5, right? This is where those two equations, if graphed, intersect. Okay, after doing those two previous problems, one by substitution method and one by the addition elimination method, let's just say that our problem now can be solved by the method of our choice. Well, I'm just going to go ahead with the substitution method. So let's start off with one of the equations and solve for either x or either y. I'm just going to go ahead and take this top equation, 4x squared plus y equals 0. And now I'm just going to go ahead and solve for y. So looks like I would have to subtract 4x squared from both sides. So I get y is equal to negative 4x to the second power. Right? So y is equal to that. And I'm going to take that and substitute it into that other equation. So that other equation was x to the third minus y equals 0. So yes, I'm going to take that and plug it in right there. So x to the third minus, and instead of writing y, I'm going to write what I just found and said what y was. It's negative 4x to the second equals 0. So the important thing here is to understand that there is a negative sign between the x to the third and the y, and then y is also negative 4x to the second. So we get x to the third plus 4x to the second equals 0. Alright, so looking at this, we would first need to try to find a GCF in factoring this. So they both have x's in common, right? So in having x's in common, we look at the x's and say, what is the smallest exponent of the two x's? Well, it's a 2. So x to the second is the GCF. So dividing x to the second into x to the third, we get x. Dividing x to the second into 4x to the second, we get 4. We set it equal to 0. There's no more factoring that we can do. So we use the zero product principle and say x to the second is equal to 0 and x plus 4 is equal to 0. And just solve each one for x. So of course, if we solve x squared equals 0 for x, we're just going to get x is equal to 0, and on this side we get x equals negative 4. Alright, so the next thing we're going to do now is just go ahead and plug the 0 and the negative 4 into any one of the two originals. So I'm going to go ahead with the x to the third minus y equals 0, x to the third minus y equals 0, and I'm going to plug those in for x, those two values that we just found. So 0 to the third minus y equals 0, and we have 0 to the third is just 0, so 0 minus y equals 0. And then it just looks like for us y is going to equal to 0. Alright. On the other side, we have x to the third minus y equals 0. We're going to plug in a negative 4 for x. So we have negative 4 to the third minus y equals 0. So negative 4 to the third power gets us a negative 64 minus y equals 0. And then we go ahead and solve for y. Well, we just add 64 to both sides, and we have negative y equals 64. Well, we know we can't have a negative variable and saying that the negative variable is what we've solved for, so we're going to either multiply or divide both sides by negative 1. It's your choice. And then we just get y equals negative 64. So it looks like that the two ordered pairs are 0, comma 0, right? The zeros are x and zeros are y. And on this side, negative 4, comma negative 64. So these are the two ordered pairs that satisfy this system of nonlinear equations in two variables. So I hope you've enjoyed this, and I hope you've gotten a lot of help from this video and a lot of tips that you can use. If so, be sure to like, subscribe, and share. Thanks, and have a good one.